Hello everyone. Very good evening, very good afternoon to everyone. Welcome you back to the session of engineering mechanics. So the last class I have conducted was on the subject called engineering mechanics, where we have done a Maha revision. In that Maha revision, I have gone through the major topics of the engineering mechanics which may be important for the GATE examination. Now in our today's class, I will be conducting the engineering mechanics class in order to make you uh, understand with the most important questions that may be important for the GATE examination. So considering this series, Super 20 series, where I will be solving the questions, important questions of engineering mechanics. So if you are solving the questions along with me, then it will be more beneficial for you. If you are not solving, then definitely there will be a requirement to have an introspection within yourself. Why? Because when you solve the question with yourself, then it will create the confidence in you. So it's better if I'm solving the question here, parallelly you are also supposed to solve the question. Or I can give you the time before solving the question where you can analyze, introspect yourself whether you are able to solve that question or not, right? So moving forward with the subject called engineering mechanics. The first topic that I will be taking is static equilibrium. This question is supposed to be an important one because from a static equilibrium, if any questions comes, then this kind of a question can be more important, right? So what the question is saying, determine the moment about the point O. Point O is this. Due to the force acting at the end of the railway post. At the railway post, this is the force acting, right? 150 Newton and 150 root 3 Newton, right? So you need to determine the moment here. So moment at this point you need to determine. So when you talk about the moment at point O, what you are supposed to do? You need to take the moment due to these load, right? This is a vertical load and this is a horizontal load, right? So vertical and horizontal loads are the two loads given here. You need to consider both and need to take the moment at point O. So considering this, 150 root 3 into the distance 1.5, right, is the moment at point O due to this load, right? And the moment is clockwise. The moment is clockwise, correct? So the moment is clockwise. Now when we talk about this load, this is giving you the anti-clockwise. This is also again giving you a clockwise moment. This is 150 into 3.5. Again it is a clockwise, correct? So the moment this and this you need to add, you will be getting the value, right? So 150 root 3 into 1.5, this is going to be 389.7 kilonewton meter, and this moment is clockwise. When you talk about this, this is going to be 525 kilonewton meter, sorry, Newton meter, right? So this is Newton meter clockwise, this is Newton meter clockwise. So what is the moment at point O? The moment is 914.71 Newton meter, and this is again the clockwise, right? So this is going to be the net based question, in a GATE examination. Can be like this, right? So I hope this question is clear to you. And if somebody will ask you what is the moment at A, so moment at A will be due to this load only, because the point of action of the load of 150 Newton is not creating any perpendicular effect with respect to A. But with respect to A, 150 root 3 is creating a perpendicular effect because this distance is perpendicular to this load, right? So moment is 150 root 3 into 1.5. Again, it is going to be a clockwise. So this is going to be 389.71 Newton meter. Again, it is going to be a clockwise. Answer is this. I hope this question is clear to everyone. I hope this question is clear to everyone. Are you getting it? Sorry. Now, coming to this question. How many of you can do this? You have a time to solve this question. Okay, yeah. 90-second time you are having to solve this question. Give the answer of this. A rigid body has been loaded as shown in a figure. Determine the moment about the point P1 and P2. What is P1 and P2 is mentioned here in a question. Also find the reaction at the fixed joint. Fixed joint is this. Chaliye. Let's see this question. Let's see this question. Now, As you can see in this question, you have a point P1 and P2. First, we analyze point P2, right? So, moment about point P2 is 150 root 3 into this distance, that is 4 root 3, right? And the effect is clockwise. When we talk about this load, the effect is anti-clockwise. Right? $1800 minus 600. So this is going to be 1200 Newton meter, that is clockwise. I think it is clear to everyone. Clear? Now when we talk about the moment at point P1, so in that case 150 root 3 into 4 root 3 is the moment at this point, and this moment will be carried forward to this point, right? So this is 150 root 3 into 4 root 3 due to this load. Now when we talk about this load, this is upward and this is causing the negative effect, that is anti-clockwise effect, that is 150 into 4 plus 5, that is 9, and that is anti-clockwise. So MP1 if I talk, this is going to be a clockwise also. So this is the answer, and this is the answer. I hope this is clear to everyone. I hope this is clear to everyone. Done? So moving forward to the next question. Now you can see this is a truss consisting of a member AD, AC, AB, BD and BC is subjected to a vertical load or the force of 120 Newton at joint B. This as shown in a figure. AD, DC, BD are each of 1 meter in length. everything is AD, DC and BD is 1 meter length. The magnitude of the force BD. Okay. So when you consider the joint D, right? First of all, I would like to have the solution of this question from you based on okay, right. So give the answer based on your understanding. I would like to have the answer first from you, then I will be solving this question. Am I audible? Am I audible? Am I audible now, Jitender? Okay. Now, let us see this question. This is a 90 degree, right? This is 30 degree. So what is the angle? This is 120. The summation of the triangle angle is 180. So this is going to be 60, right? So moving forward, if this angle is 60 degree, this is 30 degree, and this is 90 degree. So T1 cos 60 degree, right? If I say the direction of this is like this, right? And when we talk about this T2, so this is T2 cos 30 degree, right? This is, I hope this is clear to everyone. So this is going to be, if I say sigma fx0, so this is going to be equal, right? Cos 30 cos 60. I hope this is clear to everyone. I hope this is clear to everyone. Clear? Right. This is the hint. Just a moment. Right. Huh. So where we were? Yes. So it is T1 cos 60. It is T2 cos 30. Is it clear? So this is the ratio. Now, नहीं, अभी नहीं. Right? This is, so T1 by T2 cos 30, right? So this is going to be root 3 by 2, right? So root 3 into root 2 It is 1.22. Just a moment. Am I making any mistake here? Cos 60. Okay. Okay, done. I think there is some mistake I've done. What is the mistake? Let me check. This is going to be a cos theta. This is going to be a cos theta. Okay, done. It is correct. So T1 divided by T2 is cos 30. Cos 30. Okay, right. Divided by cos 60. It is correct. So what is the ratio? What is the ratio? What is the answer for this? Answer is 1.73. Correct? हाँ वो हो जाएगा. अब बोल दो एक मिनट. वेट कर लें उनको, है ना? एक बार बोल दो वेट कर लें. ठीक है, बोल दो. हाँ, बंद कर दो. So what is the answer for this? 1.732. Correct. Now based on this, can I have one more thing? As you know, this is a horizontal component we have talked about. There will be some vertical component also. That vertical component will be T1 sine theta, right? So T1 sine theta, here it is T2 sine theta, that will be equal to 200. So if you need to determine the T1 and T2 based on two equation, two unknown, you can solve T1 and T2 also. But the answer will be B. Answer will be the B. Now, this is going to be the correct also. Both the statement. This is a multiple selection choice question. MSQ. So this is also correct. This is also correct. How this is correct? Vertical component of this, right? This is going to be so this is going to be T1 sine 60. This is again going to be T2 sine 30. So this is both up and this force is down. So T1 sine 60 plus T2 sine 30 is equals to 200. This is equation number 2. Right? So by taking the T1 from here or the T2 from here, you will get the value. Answer B and C is correct. Statement B and C is correct. Now coming to the next topic, that is friction mechanics. This is a question. 100 Newton block A rest on 150 Newton block B, where block B is resting over the surface. The surface is horizontally rough surface. The block A is attached to the weightless horizontal string attached to the wall. Let's say this is a wall, right? The force P is applied on a block B, as you can see here. So if on a block B, if you apply the force, this is going to be P cos 45 correct? This is going to be P cos 45. Mu1 and mu2 is given, right? Determine the tension force in the string. Determine the external force if the body tends to move towards right. Now, what is the answer for this? As you can see in the question, the force is moving here. What will happen if we need to have the free body diagram for this question, right? This is a body A where the string is connected having a T force as a tension. So if the B is moving forward with the force called P cos 45, right? And here it is a vertical force P sin 45. This is on B body. So if B body tries to move in this direction, A body is resting over a B body, therefore A body will also try to move in this direction, right? But A body is connected to the string T. In T, the force is opposite. This tension force is opposite to the motion of the body B. Therefore, there will be a friction force introduced, Fa. Are you getting it? The body A has a weight, WA, and opposite to this WA weight, there will be a normal force, NA, right? This Fa force will be complementary over the surface of body B, that is opposite and equal. This force will be exerted on body B as opposite. This body has its own weight WB. This body has a opposite normal reaction. That opposite normal reaction I will be representing with a different color, that is NB. And there will be a opposite force due to this force, that is friction force, that is FB. So this is a free body diagram of A. This is a free body diagram of B. Now you need to analyze this free body diagram and determine the force. Let us start solving this question. Right? What is the force T in the string? First, the question is this. Question is this. So moving forward, let us solve this question. This is T force. This is Fa. This is Na. This is going to be mass into gravity, and the weight mass into gravity is given in Newton. This is a weight is given. This is a weight 100 Newton. Clear? So if I say what is friction force Fa, so you will say it is going to be a coefficient of friction mu into Na. The value of mu is given to you, that is 0.25 into Na. Now coming to the Na, if I talk about Fy is equals to 0, Na is going to be equal to Wa, right? That is going to be 100 Newton. So this is going to be 0.25 into 100 Newton. So what is the friction force? This is 25 Newton. This is called Fa. Right? Now coming to the body, this is all about a body. Now we talk about body B. This is the weight of body B, which is mg, and given in a question, this weight is given in a question, 150 Newton. Opposite to this weight, there will be a normal force Nb, right? And the force acting on a body B is P cos 45 degree and P sin 45 degree, right? Due to this force, there will be a friction force Fb, that is mu2 into Nb, that is mu2 into Mb. Clear? Now moving forward, what are the forces exerted by the body A on the body B? So the forces exerted by the body A on the body B is Na, and one is Fa. This Fa is mu1 into Na, that is 25 Newton. Correct? So now, based on the solution, I can determine the T. Sigma Fx को 0 रखा, and we will be getting the T force here and the Fa force here, that is equals to 0. So what is the tension? What is the tension? What is the tension force? This is going to be, just a moment, this is T opposite, this is, okay, yeah. This is going to be equal to Fa, that is 25 Newton. So what is the tension force in a string? As asked in a question, what is this T force? This is 25 Newton. Now determine the external force. If the body tends to move towards right, If the body tends to move towards right, what is this P force? Right? So now you need to solve this question. So in this case, P cos 45 will be equal to FA 25 Newton plus FB, that is mu2 into NB. Mu2 is given as 0.30 in our case in a question into NB. So this is given as 0.30. Now, what is the value of NB? First, we need to determine the value of NB, right? In order to know the value of NB, first, what is the value of NA? That is 25 Newton, right? I hope this is clear to everyone. Great. So, what is this sigma Fy? If it is kept 0, so it is Na downward, Wb downward, correct? P sin 45 upward, correct? NB upward, and that all is 0. That all is 0. What is Na? What is Na? So, sorry, Na is not 25. Na is 100. Na is 100. So, Na is 100. What is Wb? Wb is 150. What is P sin 45? It is P by root 2. What is NB? That we need to calculate. So, considering this, NB value is going to be 250 minus P by root 2. Is it? So, if I put the value here, NB, (250 minus P root 2), right? So, in this equation, if I put the value, right? So, P cos 45 is equals to 25 Newton plus 0.30 and putting the value of NB here. This is what? Here I put the value of NB. So by putting the value of NB, you have one unknown in this entire equation, right? What is that unknown? P. What is that external force? P. You can easily calculate now. $108. This is going to be the answer. So what is the external force to move this body in a right direction, in a rightward direction? 108.78 Newton. I hope this question is clear. Okay. I've solved this question in the last class. Okay. Sorry for the inconvenience if I've solved this question in the last class. Now, what is the answer for this? Determine the state of the block of the following figure. Give the answer of this. "90 seconds you are having to solve this question. Solve it. Done. Let us solve this. This is cos component, horizontal component. This is vertical component. This is the weight. This is going to be the normal force. And due to this force, when the body try to move, there will be a friction on this surface. And that friction is represented by F, that is 0.4 into Na. So Na is equal to W, that is 100 Newton. So this friction is going to be 0.4 into 100, that is 40 Newton. Now, when we talk about sigma Fx0, right? 50 cos 45 in this direction, right? Minus 0.4 into Na, that is 40 Newton in this direction, right? So what is this? This is 70.71 Newton, and this is, so there will be, this is not equal to 0. When the force is not equal to 0, this force is greater, this force is smaller. So there will be a body that will help the body to be in motion. There will be a motion in a body. Is it clear or not? I hope this question is clear to everyone. Simple. चलिए, moving to the next question. A block of mass 5 kg is resting on a rough surface with a coefficient of friction 0.20. The force of 5 Newton is applied to the block. The friction force is, right? The friction force is, first of all, G value you consider here as 10 meter if it is not given, right? So, considering this, we have one block of 5 kg. This weight is acting downward, resting on a rough surface, right? So the coefficient of friction is 0.20. Therefore, there will be a friction. Friction is 0.20 into normal force. What is the normal force in this case? The normal force will be N. And what is this N value? Will be, because this is the weight, right? This is going to be 5 kg also. Okay, sorry. This is not the weight, 5 kg. This is not the weight, 5 kg. This is the mass, 5 kg. Right. So if it is a mass, so it is going to be 50. Correct? It is going to be the 50. Now, when I write like 50 here, sorry, yeah, it is 10. Yeah, 10. Right? So friction is 10. Friction is 10. Yeah. What is the force applied to the block? That is 5 Newton. Correct? The friction force is 10 Newton. Are you getting it? Answer is D. Now moving to the next topic, that is called translation motion. This is the question in front of you. The time variation of the position of a particle in a rectilinear motion is given by 2t cube plus t square plus 2t. If the velocity and the acceleration of the particle is consistent unit, the motion started with. How many of you can do this? How many of you can do this? No. No, 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 beta. Let me come to Jitender. Wait. Okay. This is the question you're talking about. Right? This is the question you're talking about. Now when the body will be not in a motion? Question is this. When the body will be not in the motion, when the resultant force is 0 in a horizontal direction, right? As you can see this, 50 cos 45 just a moment, 1 root 2, yeah, 35.35. This is 35 Newton. Is it or not? Now, what is this? 0.4. What is this? Into Na. Na is what? 100. So Na is equal to 100. So by putting the value 100 here, right, it is going to be 40. So the resultant force is not equal, as you can see here. Now what I mean to say is, right, the resultant force is not equal in a horizontal direction. Are you getting it? Sure? Chalo. So if it is not equal, there is a chances of the motion of the body, right? But listen carefully. This body cannot have this option. This question does not have this option correct. This option cannot be correct. The rest means when the total horizontal force is 0. So obviously B. Now moving to this is correct. This is non. Now moving to the translation motion. I will be giving you a time for this question 120 seconds to solve. Right? After that, I will be helping you out in solving this question after 120 seconds. 2 minutes you are having to solve this question. You are having 2 minutes. Solve it. Have you solved this question? Done? So, moving to this question, Jitendra, I think your doubt is not still clear. Is it clear, beta? Is this doubt is clear, beta? One mistake is there. We have not taken this value in sigma Fy. That is why Na is wrong. That is why F is wrong. I have later on checked when I have told you, because if the external force is greater than this force, if the external force is greater than this force, then only the motion is possible. And the motion is possible. Answer is B is correct. But the calculation we have done is slightly wrong just because we have not taken this force by mistake, right? So we need to take this force. So sigma Fy 0. Jitendra, for you, because the moment I've told you the solution as correct, as in motion, it is still correct. But the calculation I've done is wrong. I have not understood your questions exactly what you were asking me, right? So here I will be putting the effort again over the same question just because there was a slight error in solving the question, because I am not taking this by mistake. Na F sine 35 is equals to W. Now it is correct, right? So by this, Na value will be W plus F sine 45 and sine 35. Correct? Are you getting it? So this Na is upward, F sine 35, 45 is upward, W is downward. That is 0. This is sigma Fy is equals to 0. Now, putting this, what is the value of Na? Na will be 100 minus 50 sine 45, 50 this is going to be 64.64 Newton. When it is 64.4 Newton, so the friction force will be, this is going to be correct. this force is greater and this force is smaller, the net resultant force is not equal to 0. Therefore, there will be a motion. Right? There will be a motion. So, listen carefully. Friction force maximum can be up to F external and at this position, this is a rest position, right? Maximum force is less than the external force, there will be a motion. This you need to understood. Now I think your doubt is again clear. Jitendra Yadav, is it 100% clear to you? Yeah. Sorry, it was my mistake. I'm not taking this force in consideration while solving or putting this equation. So that is why the answer was correct, the concept was correct, but the mistake was in a calculation, right? I corrected it. Now moving forward to this question. This is representing the position equation of any particle after time t, right? So the velocity is defined as the change in a position with respect to time, that is called velocity, and you need to determine the velocity. So what is acceleration? It is called the change in a velocity with respect to time, right? So what is v? V is dx by dt, right? So can I write d square x by dt square? Now this is going to be 60 square plus t correct? This is plus 2. Now based on this is 12t plus 1, right? Just a moment. I think we have done the mistake. First of all, 6t square 2t and this is 2. Now it is correct. Differentiation of t square is 2t1, right? And this is 2. Okay. Now this is 12t plus 2. Correct. So you have two equations. So equation 1, when you put the answer, motion just started, right? So at time 0, this is going to be 2 . And what is the acceleration at time 0? This is acceleration. So answer is D. Velocity is 2 meter per second and acceleration is 2 meter per second square. I hope this is clear to everyone. This is clear to everyone. Done. This is our next question in front of you. Can you solve this? Yeah. Solve this. Can you solve this? I think I've given you ample time to look at this question. Now see, a particle moves along a straight line. Here the variation is variable. The acceleration is variable. So means there is not having a constant acceleration. That means what is the variable acceleration? The variable acceleration means if at time t1, let's say the acceleration is x meter, at time t2 it is x plus 2 meter per second square. At time t3 the acceleration is right. So what is the change in a velocity? The change in a velocity is not constant. This is called a variable. Speed change with respect to time. At different time the speed is changing with a different, the speed is changing not constantly, right? So this is a variable acceleration. So in this question you have given a variable acceleration. The variable acceleration equation is given you as this. The initial velocity is asking what is the initial velocity. The initial velocity is determined when the time is 0. So we need to determine this. At time 0, what is the initial velocity? if the particle displacement at time 0 is same as the displacement of the particle at time 4. So displacement at time 0 is same as displacement at time 4 second. At fourth second the time at the fourth second of time the displacement is same, and whatever the displacement is there at a 0 time, so it is same. This is given to you, correct? We need to determine the velocity of the particle at 4 second when the time is 4 second. So final velocity we need to determine when the time is 4 second. This we need to determine. This and this is given. Correct? Now, how to calculate the velocity? As we all know, the acceleration is defined as dv by dt. Is it or not? Everybody knows. So can I write dv by dt is minus 2 plus 3t? Can I write like this? So in order to determine the velocity, we need to have the velocity equation in hand. In order to determine the velocity, we need to have a velocity equation. So how you will be having the velocity equation? So acceleration is dv by dt, that is minus 2 plus 3t as given in a question. Correct? So this is acceleration. Now, based on this, can I write like this? And if I do a integration on both the side, I will be getting the velocity here, and the velocity equation I will be getting, it is 2t plus 3t square by 2. Correct? Plus T1 constant. Right? What is displacement? What is displacement? What is displacement, beta? So displacement is defined as, velocity is defined as the change in a position with respect to time. What is velocity? Velocity is defined as the change in a position with respect to time, and that change in position is basically representing a displacement. So displacement with respect to time. So ds by dt is the velocity. Correct? ds by dt is the velocity. So can I write this? Can I write in this way? So if I do again the same thing, I will be getting the displacement equation. Right? This is dt. Now see, if I do a integration here, what will happen? ds minus 2t plus, so plus 3 by 2 just a moment, minus 2 t square by only t square, okay, plus can I write like this equation, right? So here you will be getting the displacement equation, t square by 2 t cube by 3 again one constant created, that is C2. So what is the displacement equation here you will be getting? Minus t square, this is cancel, this is t cube by 2 plus C1t plus C2, right? So what is the displacement at time 0? When the time is 0, you will be having the displacement 0, 0, 0. This is going to be C2. So at time 0, the displacement is C2. What is the displacement at time 4 seconds? Therefore, it is C2 since it is given. Since it is given. Correct? Since it is given. Chalo, right. So by putting the equation, I will be getting the value of C1, right? I will be getting the value of, so what is the displacement at time 0? It is defined as S0. So what is S0? S0, okay, done. This we have got C2, okay. Now at time 4 second, let us talk about 4 second. What is the displacement equation? In the same displacement equation, if you put the values, minus 4 ka square plus 4 cube by 2 plus C1 t is 4 plus C2, correct? What is the displacement at 4 second? It is nothing but C2. So tell me what is the value of C1? C2 and C2 is cancelled. Here, if you take this C2 here, this will be minus C2. So what is the C1 value? You will be getting 4 ka square, 4 cube by 2, right? This is equals to 4C1. So C1 will be 4, right? 4 cube by 2 into 4. So 4 square by 2. Correct? This is going to be the value of C1. So what is the C1? What is the value of C1? 16 divided by 2, that is 4. 16 divided by 2, that is 8. 8 and this is 4. So it is going to be minus 4. What is the value of C1? Minus 4. if you put this value -4 in the equation, now put value of c1 minus 4 in equation of velocity, right? What is the equation of velocity? This was the equation. Yes. This was the equation. So, V, initial velocity. So, by putting the value of t is equals to 0, you will be having 4 meter per second minus initial velocity, and at 4 second, this is the final velocity. What is it? -8 plus 3 into 4, 16 into 3, okay, by 2 minus 4. This is going to be velocity at 4 second. This is going to be 12 meter per second. This is the answer. Done. I hope this is clear. Right? This question is again clear to everyone. Right. Now we have a last question based on collision theory. One question we will see based on the collision theory. A ball of mass 1 kg moves with a velocity of 2 meter per second, undergoes a direct impact on a stationary ball. Let us say this is a 2 kg ball which is stationary, and this is a 1 kg ball which is moving with a velocity of 12 meter per second. Since this is a ball which is stationary, so therefore its velocity is 0 meter per second, right? The collision is assumed to be perfectly elastic. Okay, so this is the situation before collision. Before collision situation. Determine the speed of 2 kg ball after the impact. Impact means after collision. So what happened? After collision, this ball will create the impact, that is the 1 kg ball over the 2 kg ball, and the 2 kg ball starts moving with some velocity. We do not know what velocity, and we do not know by what velocity the first ball starts moving. But since the case is perfectly, this is before collision, this is a case of after collision. So they are asking you about the after collision impact speed, right? After collision, what happened? They are asking you about the after collision effect. So let us see. So since the case defined perfectly elastic, in a perfectly elastic, we talk about the velocity of approach, right? Before collision. And when we talk about the velocity of approach before collision, So u1 is always greater than u2, and here if you see the velocity of approach, this is u1 minus u2, this is going to be how much? 12 minus 0, since it is stationary. But when we talk about after collision, we talk about separation velocity, and after collision, when we talk about separation velocity, so at that moment of time, the velocity of the first ball, which has a velocity of 12 meter per second before collision, that will have the velocity reduced with respect to the ball which starts moving after the impact. That is a stationary ball. That will have the greater velocity, and the velocity of separation in this case v2 minus v1. We do not know what is v2 minus v1. And the ratio of velocity of separation divided by velocity of approach in a perfectly elastic case is E is equal to 1. So therefore v2 minus v1 divided by u1 minus u2. Right? This is the first equation. So u1 minus u2, this is what? This is called coefficient of restitution. This is going to be 12. This is going to be the first equation. Right? Now, this is going to be the first equation. Correct. Now, moving to the next case, we are having the two unknown, v2 and v1. Right? Sorry. This is 12. So v2 minus v1 is equals to 12. This is the first equation. Now, okay. So now, second equation is momentum equation. Momentum equation. When we talk about the momentum equation, m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Total momentum before collision, total momentum after collision is constant. So, the ball has a mass of 1 kg with a velocity 12. Second ball has a mass 2 but has velocity 0. First ball has a mass 1 and the velocity is unknown. Second ball has a mass 2 kg but the velocity is not known after collision. So v1 plus 2v2 is equals to 12. This is going to be the second equation. You are having two equation v2 minus v1 is equals to 12. This was the first equation. Two equations, two unknown, you can solve and you will be getting the value of v1 and you will be getting the value of v2. Very simple. Can you solve? Okay. So solving these two equations, you will be getting the answer. This will be going to be this, and this is going to be this. Now what does it mean? Minus is representing what? So V1 is this, moving with ball 1 of 1 kg, moving with velocity of 4 meter per second, but after collision in opposite direction. अपोजिट डायरेक्शन में मूव कर रही है बॉल आफ्टर कोलिजन, मूविंग विद अ वेलोसिटी ऑफ 4 मीटर पर सेकेंड, बट आफ्टर कोलिजन in opposite direction. Why? Because it is minus. Now what is V2? This is 8 meter per second. This is what? Ball 2 of 2 kg, velocity after collision, moving forwards. आगे की तरफ जा रही है बॉल टकराने के बाद. तो बॉल ये थी, बॉल ये थी, टकराई, तो सेकंड बॉल तो इस डायरेक्शन में मूव करने लग गई, फर्स्ट बॉल टकराने के बाद इस डायरेक्शन में मूव करने लग गई. इसकी वेलोसिटी 4 मीटर पर सेकंड हो गई टकराने के बाद, ये आगे की तरफ बढ़ गई, दैट इज 8 मीटर पर सेकंड. वेरी सिंपल. आई होप दिस क्वेश्चन इज क्लियर टू एवरीवन. चलिए, थैंक यू एवरीवन. आई होप this is going to be very beneficial for you. These questions are going to be helpful for you for the GATE examination, because I have solved the best questions that can be possible from the engineering subject, engineering mechanics subject. So I have solved the most important questions that will help you in a GATE examination. So practicing this question, this type of a question, will boost your confidence if you solve the same question again after the class. So it's not, I'm not saying the same question will appear in examination, but the similar kind of a question may appear if the question comes from the engineering mechanics. So thank you everyone. Looking forward to see you after the exam in a paper analysis. Thank you. Thank you.